So let's talk about this amazing benchmark that keeps. I wish they would stop, but they wouldn't stop. We talked about the loops thing.
Yep.
Unfortunately, they then continued and they did this Levenstein distance bit.
For those
And
that
of
don't know,
course,
Levenstein is what you take two words and it calculates the difference between them based on letters. It's like add, remove, and the same. It's
Insert,
kind of like a
delete.
Git algorithm in some amount.
Yes. And so it's just a way of comparing two strings. You could think of it. It's like it gives you a comparison of two strings. That's trying to be something about their similarity.
Yeah,
right? Like
it's
how
the distance betwixt two strings, if you will.
Yeah. And of course, then we got another one of these bouncing ball things, right?
Oh man, Fortran's kicking C's ass.
And the person who made this posted literally a tweet. In fact, I don't know if we can get the. Oh, you can't guess on here because I'm not logged in. I guess on Twitter you can't do that anymore. But posted a tweet that was like, "Fortran out there really impressing," was the slug for this. I guess I'll call it a graph, but that's being charitable, right? This thing, whatever this is. And they said that, of course, because if you look, and you can't see it, neither can I, but if I zoom in here on the top in a way that would make it actually visible, what you can see is that Fortran is outperforming C, even. Not to mention all of these other languages you're talking about. Odin, Zig.
My favorite is that Objective-C beats Rust. I mean, I personally just love to see it.
Rust, obviously, and not by a little. Right? Fortran is crushing these languages, right? It's like, Ginger Bill, what were you doing? Why does it take 10 milliseconds longer to run this in Odin than it does in Fortran, which has been around since the 70s, right?
57, if I'm not mistaken.
60s, sorry. Yeah, 60s. What's going on? You guys just don't know how to program, all of you people in the bottom of the list, right? That's obviously what's going on. And that's the problem because, again, that I'm saying that in jest, obviously, but people believe that. Like when you tweet stuff like this, when you do a benchmark like this that's done very poorly, and then you tweet something like this, people don't take it with a grain of salt. They literally think this means that Zig is half the speed of Fortran.
Yeah,
that's what they think when they see
this. Hit with that.
That's what they think. Right? I guarantee you that there's a bunch of people who are like, oh, wow, if I took my Zig code and rewrote it in Fortran, it would be twice as fast, is what they're thinking in their head.
Yeah, which is also a really hilarious tweet to be like, why choose Zig when you could just choose Fortran and get double the speed?
Right? And so at that point, it's creating a real problem. It's creating a real misperception. This is not a harmless thing to get traction. If this was just someone tweeting into the void, that would be fine. But for some reason, people are paying attention to this. I really don't know why. I guess just because it feeds into their ability to make their own stuff or make their own quick comments without looking into things further. So it's unfortunate. But as a result, this is a very damaging thing that has happened because these graphs are out there and people are that is an inference that they are making about these languages. I randomly picked Zig in that case, but obviously it's true for all of these, right?
Yeah.
It's true for any of the ones that are up on here. And there are some languages down at the bottom, like Ruby and Python and stuff, that are going way, way slower. So maybe you're not making a real comparison between those two. Like maybe people aren't comparing the bottom of the list to the top so often. But tons of people are looking at this top list and going, oh, wow, yeah, like Fortran, twice as fast as all of these languages, twice as fast as Go. It must be the garbage collector, right? They're making all of these statements, but no one's looking, right? No one's actually looking to see why. And we showed that on the last time when that really bad part of this benchmark, the loops test in this benchmark, I was kind of trying to give people some perspective on why that was such a bad benchmark. Well, here's the Levenstein distance one. Let's talk about why this is such a bad benchmark. Well, there's a number of reasons why it's a bad benchmark that are subtle, like the last time, but let's just start with one that's not so subtle, which is why Fortran is performing so well on this benchmark relative to languages even like C. That's a significant difference. That's over 10% speed difference, even than C, let alone these other languages. Zig should just be compiling like C, right?
They,
Like,
they
so
really,
why,
yeah, C,
right?
Rust, Odin, Zig. I would just assume they all should
I would have
theoretically
too.
behave the same, especially since I think they all have LLVM anyways, right? Like it
They're
should
all using
theoretically be
LLVM
the same.
backend.
Yeah,
So what's going on here, right? Like, I don't reliably think it's good. So Fortran, let's just take just the
it's
reason
cheating. That's why.
why is Fortran? Sorry, what?
It's cheating. Obviously, Fortran's somehow skirting around work.
Well, that's one way to say it, but let's take a closer look at what's going on here, because that saying that might be generous, let's say.
Ooh.
Um,
Ooh.
so let's start by doing what I encourage everyone to look into these things, like learn more, look into them. Don't take this sort of stuff at face value, because it's very common nowadays that a benchmark will be made by someone who doesn't really know what they're doing. And so if you just take it at face value all the time, you're going to be badly misled, right?
Yeah.
So anyway, let's start by pasting the C version in, as I always like to do here, into Godbolt.
I forget how
And I'm
hard
just
that
gonna
algorithm is. It's a lot of for loops. I remember that now. Okay.
yeah, and I don't know. This looks like it's visible enough on stream. Hopefully, the compression is not
Yeah,
too
compression kind
horrible.
of sucks, but we'll just try to get through it.
We'll roll with it. So okay, so what I'm going to do here is I'm just going to use GCC in this case, because G Fortran is probably what I'm assuming what they were using to compile with, but it's a Fortran compiler we could use, so we can compare sort of very like to like, right? G
Okay.
Fortran and GCC.
I think you can
should,
find out actually pretty easy with that one. I can find out.
yeah,
Later
there's
on
a
that
build. There's a build.sh you can look
Yep.
at it, but I'm assuming they're using G Fortran. But even if they're not, this is fine for us because we can run. I'll run it with G Fortran, so we'll be able to see and verify the results in a second here. So if we go ahead and do an optimized build in GCC of our C code, I'll save everyone the trouble of trying to read all this on stream, obviously, and just explain that this part right here of the code is sort of the heavyweight part. What I mean by that is, if you look at the way this code is structured, there's a main loop out here that loops through all pairs of strings. So it's n squared. If you pass this thing n strings, it has to do n squared comparisons. And the only exception to that is that it's not going to compare a string to itself, because it knows the distance is 0 for that, right? But it means there's an n squared loop on the outside, and then the strings themselves get looped over. So there's like another n squared loop on the inside. So that means there's an n squared loop running an n squared loop. So this is like an n to the fourth kind of a situation, right?
Yeah, that sounds right.
Which means that this is the hotspot of the program for all intents and purposes. This is what will be run the most. So barring other kinds of issues, which of course there can be. So, when I looked at this, I was looking at it pretty carefully, but I'm skipping a bunch. This is where we would expect the time to concentrate if the programmer or the language hasn't done anything too stupid about other things. Like if they haven't inserted some really ridiculous stuff elsewhere in the program, our time is going to be spent inside this loop. That's what's going to happen. So the first thing I do here, just to, because it's free for me to do it, I just, I could do it while I'm reading Twitter and I see this thing pass by. I go, okay, where is this? What's happening here? Like, where is this loop existing? And I want to come over here and just find it, see if I can find it. And what we can see is it's basically right here. This is the loop.
Can I ask a quick, kind of dumb question?
Yes.
Is there any reason for the coloring other than showing you just separate statements?
It corresponds the two together to a certain extent, right? So do you see how that's green and this is green?
Yeah, I was
that's
wondering, is there like
this...
a reason? Is there like a certain type of statement that always gets highlighted green versus a certain type of statement that always gets highlighted red? Or is this always just, because I just have always just looked at it as random colors. So I just wasn't sure if it's just trying to disambiguate for your eyes.
It corresponds side to side.
Okay. So it's just for you to be able to help look into this graph just to make sure.
Yeah, so like when I'm hovering over, you'll notice it's like it highlights that is this code is for this, right? Or whatever. That's what the highlighting is supposed to be telling you. That's what the color is to correspond. Like this corresponds to this, right? So they're both tan.
Mm-hmm.
That's it.
Okay.
That's all it's trying to do.
Okay. I wasn't sure if there's also like some sort of grouping of instructions also that infer some of these colors. Like, oh, when it's green, you know it's this. If it's red, you know it might mean this. But okay, that's fine.
No, it's just
I wanted to
side
make
to
sure I
side.
understood it. Okay.
Just side to side, as far as I know. I mean, someone correct me if I'm wrong about that, but I didn't think there was any other rhyme or reason to the color, like, oh, it'll prefer tan if it's a declaration of a constant or something.
Okay.
That I don't know. But I certainly don't use it that way. I'm just looking for correspondence there. But I usually also just highlight like this, so you can just quickly see like what does it correspond to. And that's not always accurate, but at least because in an optimized build it's not always accurate. In an unoptimized build it is, but in an optimized build it's not. So when we are looking at it, this is that internal loop, this most innermost part here, right? Is this code right here. So, we don't really need to walk through to know what it does. If you don't know assembly language, you won't necessarily know what that does. But I'm looking at that and going like, okay, does that look reasonable to me? Yes, it does. And you'll notice that even though, just pointing out, compilers are good these days, right? This is using a function called min. That function is actually defined up here.
Yeah.
And it's basically saying, look, start with A. If B is less than that, then pick B. If C is less than either of those two, whichever one was lower, then pick C, right? Standard ternary min right here, like A, B, and C. It's basically saying like, okay, pick the lesser of those with some if statements, right? And what you'll notice is was not declared inline, but the compiler completely inlined it. There's no call here, right? And also, you'll notice no branches. So it looked at that and goes, oh, you know what? I should branch free that. And so what it does instead is just use conditional moves. It does the comparison, but then instead of branching around the assignment, it just does a conditional move so that it doesn't have to have any branches either. So GCC correctly inlines, correctly removes the branches. You are good to go. This looks pretty good to me. So how is Fortran? What is the Fortran code doing, Prime? That's going to beat this? Did they have some kind of amazing vectorizer? Like, this is very concise code. I didn't spend a lot of time figuring out if I could shave a cycle or two off it, but it is not bad. And the Fortran code is outperforming the C code by a lot, right? Not to mention Zig and Odin and those other languages that were way worse, right? So what is the Fortran code doing here?
I don't know, but I'm excited.
Right? So let's take one more step here and say, okay, let's add the Fortran code. Oops, I didn't want to do that. Okay, good. We're still here. Sorry,
Nice.
I accidentally clicked the wrong button. We're still here. Here's that code that we're talking about. Let's add the Fortran code and see what it's doing. So I need source editor, and we'll put that down here. And I'll switch this to G-Fortran, which I believe is supported by this, does it? Or Fortran, maybe not. Wait, I was able to do this before. I know there is a Fortran. Oh, I know why. This is in the wrong language.
Yeah.
I need to add a different language. How do I switch the language? It's this there. I'm like, what the heck? Fortran, there it is. Fortran.
It was correctly giving you proper compilers.
I mean, it's never Godbolt. It's only going to be me, right?
Yep.
This is, the tool of champions.
Well, you can tell that a champion built this because what is the only two options for editor? Standard, notepad operation, and Vim, right? Like you can tell the mana class. It's a mana class right here.
What would they say? Vim Master Race or something? I don't know.
Yeah,
there's
Vim Master
probably
Race. There you go. You got it. You got it.
Okay. All right. So do I have? Let me see if I've got this set up right. I seem to have. I've definitely ruined something. There's my C source, but I lost one of my compilers. So let's add new compiler here and try to get that back. Sorry,
No, it's looking good. I see everything you're doing. It's looking right.
Operator error, right? But I just want both of these up at the same time so that you can see them both, right?
Okay.
So I'm going to do an O3 build in both G-Fortran versus GCC here. Like I'll scroll down again to our little friendly piece of code here.
Yep, you can see the inline right there in the gray.
There it is. And maybe I'll try to do this slightly differently, I guess, in terms of the way the windows are set up. Maybe because we want this to be fairly large. Maybe what I'll do is I'll just put this below this so that the the compiler, the source is the compiled version
Perfect.
is
Yeah, yeah, yeah.
below, so that we can have that be big. Because once we find the location, all we really need to look at is that code gen to see what it's doing, right? So let's take a look at the Fortran version now. Again, I have to kind of go grab it here from the Fortran version. Is there a wait? Let's open that Notepad++, I guess.
The
There we
Lord's
go.
editor. By the way, Fortran, pretty nice looking languages these days. You know, it looks pretty simple.
Yeah,
I had to
I
do a
don't
lot
have
of
a problem with
Fortran
it.
back in the day when you couldn't use the first 7 columns, and so like that
Oh,
was
really? Is that?
yeah, I mean,
Okay.
older Fortran was a really horrifying language. I mean, it looks like you could use that. You could be productive in that if you want to.
Well, unsurprisingly, Fortran pretty much looks exactly like the C code too,
Yep.
right? So there's nothing much going on here. If I pull this back down for a second here, you can see same exact thing.
Yeah, you got a 4-4 and a
with-
do-do, I think is what they have,
Yep,
right?
and a do-do. You know, nothing.
Whoa,
It's
doo-doo.
just a little do-do, a little do-do in the code there. So let's try and find where it's actually doing this, right? Let's try and find the place that actually compiled to, where it's doing this interior part, like the min here, right? To see what is it doing? Like, what's it doing differently that's so amazing? And I wish I had not quite expanded it out there because I need to be able to find this part, which is harder to do on stream than you would think.
Yeah,
but
anytime you need to do something in front of people, it always gets twice as hard.
it always is, right? It should be right around here, and it should have very similar structure, right? There it is. There it is, right there. Okay, found it.
There's the conditional moves. You can see them, so they're avoiding the branching.
So here's the code gen. And what you will notice is even if you don't know anything about assembly language, it is shockingly similar, right?
Yeah.
I mean, to the point where you've got the exact same techniques being used here. The instruction ordering is slightly different. That LEA is like it's like in between the two on this side, and it's not on that side. But it's the exact same code. And the only difference here, is that the G-Fortran compiler, for some reason, has decided to unroll the loop one additional time. So this code, as you can see, gets repeated, right? One more time here before it does a comp jump. This GCC did not do that, right? That's the only difference. No real difference. And this will persist even if we can tell it to use a much more recent instruction set if we want to. We won't really get any appreciable difference. We'll always get basically this exact same thing, where we see very similar pattern. There's like some very small differences that will occur in the code, but for the most part, it will be the same. And there's a few differences, like in the Fortran, it decides to unroll it, but otherwise they will be basically identical, right? So that's what we will see. Here's the same code again, no matter what we really do. So how is it getting so much faster? Well, one answer might be, for some reason that's not obvious just from looking at it, unrolling this loop an additional time is just a really great idea.
I just can't
and the
imagine
Fortran,
it's like 40% faster or whatever it is. It's
like close to
versus
20,
25, right? Like
yeah.
that's a huge amount, 66% slower to not have it unrolled. So I'm like, that can't
Oh,
be
well,
that can't
that's
be real.
Well, the Fortran was only like about 15% faster than the
Okay.
C version, which is the one we're looking at here. We were not looking at like the Odin one or the Zig
Okay,
one
okay.
or the right. So we're looking at this and we're going, that doesn't make a lot of sense. I don't think unrolling that loop would have made any difference. So the first thing I did just to check that, because I was like, wait, what? Is I just forced this loop to unroll twice by putting a pragma unroll in front of it. And I tested it and it didn't change the speed at all. Right?
Okay.
So I can tell you, we won't bother doing that on stream here, but I can tell you unrolling the loop makes no difference. There was no reason for the Fortran compiler to really do that. It doesn't really help in any particular way. So it was unnecessary and is not the cause of the speed up. So now we're left with this thing. It's like, okay, I can pretty much tell you that the Fortran code isn't better. We're looking at it. It's the same. Don't rewrite your code in Fortran, kids, because it's the same. It does the same thing, right? So if you were programming in C, the benchmark already very suspicious because we're looking at the assembly. And again, this tells you they didn't even spot check it, right?
Yeah.
Like the people making this benchmark do not even spot check these results. They just publish them and they leave it to other people to do the dirty work for them. It's very irresponsible and I don't like it, right? But let's go ahead and take a look now at what's actually going on then. So I obviously am like, what's the deal here? Because that doesn't make sense to me. I'm like, that can't really be a legitimate thing that's happening. Why are they getting the benchmark results that they're getting, right? And so, obviously, and hopefully I can do this here. I don't think I have I don't know if I can do a GCC. Can I do a GCC? I might be able to do a GCC of just the C version. Can I do that? Let's see if I can. Okay, great. Will it run? Will it blend? Yes. So I can compile both of these on this computer. It's not the computer I actually used to do this. I did this on my Zen 4. I have a Linux machine because I wanted to use Linux so I could use some more of the stuff that they had in there. But we can do this on this Windows machine. So let's do the exact same thing we did. We'll use the Fortran version here, and we'll compile both of these programs into executable so that we can see what the heck is going on, right? Because I just don't understand, and I want to know what's happening. So we can run both the C version and the Fortran version. They appear to be working. And so now, oops. No, Visual Studio. No. Why?
Your
I got to
debugger
change that file
gotcha.
association.
I love that your debugger also gets you.
It's just associated with C version. So I can run both versions. I can run the Fortran version. I can run the C version. So now I should be in a position to find out what the heck is going on, right?
Mm-hmm.
And the way that they're doing this, right, is if you look, they've got this thing. I took a copy of the repro here. They have this input .text thing, this input.txt, right? And I'll copy that into this directory. That is what they're using. So this is the input to the program, and these are the strings, right, that they are going to be processing.
Okay, nice. Yeah,
So
it's a square. You compare each string against every other string, so it's an n squared of whatever that is. So a lot of comparisons going on. And white space, I assume, is the how they split the strings.
I mean, a lot of comparisons. Like, okay, n squared of like I don't know, 30 or something. It's not a lot. It's 900. It's like it's so tiny, right?
A lot, maybe in like for my eyes. I look at that and go, okay, there's a bunch going in.
Yeah.
This feels like a classic leak code setup where you're going to be like, oh, bamboozled.
Yeah. So you look at this, and as you just pointed out, I think it's going to be separated by space because it's not read. You can see here, it's not read as a file. It's read as part of the arguments, right? Which is a really, really weird decision to make for a benchmark, because now you're talking about going through someone's command line parser, which is not something we would typically ever care about the performance of. There's almost no situation where that is how large amounts of data is passed. So it's a very strange decision for a benchmark, highly, highly suspicious. But I'll just say, like, that's actually not exactly the problem here. But
can I
that's bad enough.
Second? You just said it was a large amount of data after making fun of me for calling it a large amount of comparisons. I feel I feel like we're fighting now. Now it's like no longer fun.
Sorry. What I meant to say was, if you were trying to design a benchmark and you wanted to test things, you typically wouldn't test the command line parser.
Agreed.
Because you're never going to feed a large amount of data to it. I'm not saying that this is feeding a large amount of data to it. I'm saying nobody who processes 70 gigabytes of data passes that on the command line, right? Yeah. So when you're creating a benchmark, you typically wouldn't care very much unless you're just doing command line parsing benchmarks for your own amusement. You're never passing very many things on the command line. So the speed of that parser is usually not relevant to you. And so it's very strange to be constructing a benchmark where you're saying, oh, we're going to include the amount of time it takes to parse the input if it was passed on the command line. That's a very strange thing to say, right? I'm not suggesting this is much, but I am suggesting that is weird.
Yeah,
Does that make sense?
Some sort of variance that's unfair, right?
Or who knows?
Yeah.
Or what we're about to see, which is way different than that. So if we take a look at what happens here, and maybe this won't reproduce. I guess to be fair, I don't actually know, since I haven't done this on Windows before. I only did it on Linux. I don't know if this is a bug specific to macOS and Linux. We'll find out in a second here. But so we have to pass this on the command line to a program in order to get it to run, right? So let me just try to construct something where we do that. For example, if I go back to Notepad here and I make like a batch file or something, so that I can, make it a little bit easier to do that. I'll just create something here. I don't know if this will stop me. It probably won't. We'll just say this is going to be run.bat. Hopefully that worked, right? Yes. So I'm going to make a little run.bat here, and I will open up that input text here. I'll just grab that, and we'll make a little thing that runs our Fortran version with this, right? So we'll say, okay, let's go ahead and run the Fortran version with that. I guess I don't need the exe there. It should just work, right? And I'll echo off that so we don't get that dumped. So if I do run now, you can see the Fortran version runs. It runs the amount of times that the benchmark said it should, because if you go look on their page, like it should say that it ran 3906 different comparisons. That's what it should be for the n squaredness of this, I guess. That's how many things there were in there. And then the minimum distance that it reports is 7, which is the correct answer according to the benchmark, which is just saying, look, this is how many, if we took the closest to pair, the closest pair, that's what Levenstein returned for the closest pair. Does that make sense?
Mm-hmm. Yes.
Okay. So let's go one better and run the C version as well. So now, version, right? So now if I do run, I can see, okay, they both run. They both report the same results. So, I mean, prime, they both report the same results. Such stringent testing on this benchmark. Clearly, the Fortran version and the C version are doing the same amount of work. You must be wrong, Prime. You just don't understand.
I want to make up a language just to have it so I can hide in something that just literally prints out the exact answer they're expecting, but it looks really complicated. And then it's just like, oh, my made-up language does it in nanoseconds, buddy.
In the compiler. Hide it in the compiler, too, so they can't see it happening. Yeah. It looks like it's running the regular algorithm, but it just outputs the result, right?
Dude, so good.
So, anyway, what's going on here? Well, again, one thing that you might start doing now is saying, well, how sure are you that that is actually producing the same answer? Because if all you do is print out the minimum distance, that's not much of a verification now, is it? Yeah. Because all that says is that you correctly computed the answer for the smallest pair. You could have computed the answer wrong for every other pair but the smallest and still been right. You know what I'm saying?
Yep.
So it makes me go, well, what would happen, right, if I were to ask it to maybe just be a little bit better? And mind you, I have no idea how to program Fortran, so I'm just going to go in here and
close
say,
enough, it looks like.
Right?
I think, no, -1. Do a -1 because your first comparison is a -1.
Good point.
Yeah.
Yeah. I was thinking I should initialize it to something that would always fail, but that's, they've already done that for me.
I was confused why min distance was -1 because I was like, I think I would put that as like max int, right? Like I was already way off.
So maybe this, maybe this will work. Prime, what do you think? I don't know. Just copying it in there, right? Get the min distance, get the max distance.
Like
I don't know how to program. One. Let's compile it again.
Okay, I love it.
Right? Has no implicit type. Uh-oh, we've done something wrong. What did we do? Oh, is it up here?
Yeah, there has to be some sort of declaration
somewhere. Here we go.
Yeah, there it is.
Here we
go.
It is. Watch us learn Fortran on stream. So there we go. Right. Now we run it, and we get a max distance of 7, I guess. No one saw that. There we go. We get a max distance of 100, right? So that's the largest one it found. The smallest one it found was 7. The largest one it found was 100. So I know how to program C thankfully. So, it should be even easier for me to do that with the C version. Let's go ahead and check it out there. So we'll copy our min distance here into max distance. This code is very similar, as you can see. We'll just copy it here. We'll grab the max distance.
Everything,
like
it's like
before.
identical. Yep.
Almost the same, right?
Yeah.
And we'll just go ahead and print that out as the max distance, and we'll see what we get. There we go. Gosh, Prime, those don't look like the same numbers, do they?
Oh, no. Why is it...
Right?
Is there 100 in the Fortran program? Is something preventing it from searching very deep?
Who knows? Right?
Yeah,
Who knows what's happening, Prime? And I do know, but I'm amping this up for...
I love your foreshadowing.
Yeah. Because I'm so annoyed, right? I'm so annoyed that someone put this out there and didn't even, they didn't even do validation of the benchmark. They didn't look at the assembly. They didn't look at the validation, right? And then in all this, and then Hacker News and whatever else, right? It's just...
Can I throw something out there?
Please.
I think this just goes to show that as you develop one of these benchmarks and the language web, if you will, gets wider and wider, or the language net gets wider and wider, you start getting these little esoteric languages that are popping up. And I'd call Fortran at this point an esoteric language, or a very unused language. Arcane might be a better term for it. And no one can look at the code and validate it. So you have one person setting up something, and there's not rigorous testing because it's just like a side fun project. I'm just giving benefit of the doubt, right? It's just side fun project. Hey, as long as you say you do these things, you've iterated this many times, and you have this number, you're probably good to go. No one can validate it, right? Like they just look at it and they go, "Oh yeah, emoji code, cool." Right? Like they just,
But I mean,
no one can do anything about it. It takes someone going, wait a second, let's actually make it, because all you've done is just added more testing. And on the smallest dimension, you're showing right away that even with the tiniest fraction more testing, it's actually showing that this thing is broken. And how many of the other ones are broken also?
Well, that's exactly my point. And this is why I say, you got to take benchmarking more seriously if you're doing micro benchmarks.
Yeah.
Micro benchmarks are not for, whimsical side project that then you post about as if it's a real ranking, right? That is not how that goes. A real benchmark, you could do that with because you've done the work, right? Like a real benchmark, even if you're naive, you at least ran the workload and you got the result you needed and you said, this is how long it takes, right? Like the people who I pointed out with GPUs or whatever, right? The people who benchmark, they load up a game, they see how long it takes to render the frames. They don't know anything necessarily about how a GPU is working. Yeah. They didn't analyze any something but it's okay because they saw the frame. They got the frames they wanted. They know how many there were, right? And they looked at how fast they were generated. That's all you care about, right? Micro benchmarking is not that way. You haven't validated anything. If you're just looking at this one little thing, you haven't tested a real workload. You don't know if the workload has been produced correctly. It's a real problem, right? So anyway, starting there, right, and going, well, okay, we've looked at the assembly. We see no reason the Fortran version should be faster. We added a little bit of checking, and it doesn't seem like it's even computing the Levenstein distance properly, so what's going on here? Well, I actually did try to inspect the code, and I was like, here's the C code, here's the Fortran code. I'm like, actually, they look very similar, so I don't see why. I look at the assembly code, they look very similar. I'm like, something else is going on here. So I was like, what really is happening with this code? What is that doing?
Look at that.
Exactly?
Look at the 100 in there. Let's go.
Right? I'm like, what is that? Strictly out of curiosity.
No.
Is that suspicious at all to anyone else? Yeah, I'm not a Fortran programmer. Don't take my word for it.
But it does look like a conveniently similar number that was also the maximum number on the other side.
But it seems like to me, if I had to guess, that is a little suspicious.
I would be hitting sus right now for sure.
So at that point, I was like, well, let me just, maybe that's not what that means. Maybe 100 means like give it 100%. Like we're gonna
Classic percentile in computing when it comes to
right,
allocation.
like like we're gonna do, just we're not gonna give 50%. We're gonna give 100, not 110%. This isn't the football team.
Yeah, come on.
Right?
There's no
we're gonna give it 100%
around here. Come on.
Yeah. So I said, well, all right. I learned enough Fortran to know, like, okay, that's ASCII character. So, like, okay, let's print out what this thing thinks it's going to be using as the command line arguments, right?
Yeah.
Let's just see what that does. Oops, I got to do my G Fortran here. And lo and behold, Klippenstein, right?
It's not
they
the
all
Levenstein algorithm,
truncate.
it's the Klippenstein algorithm.
It's the Klippenstein algorithm, right? It actually clips its input so that the longer, the strings that were supposed to be really long aren't really long, which of course in an n-squared algorithm is a huge deal, right? Like you were going to use that string, the much longer string, to compare against all the other strings at some point. So you're now reducing that, whatever that maximum length was, you're reducing it quite a bit, right?
Oh, this is a thing of beauty. I'm loving it. I'm loving this.
Yeah, well, I wasn't loving it. I mean, I love it in the.
I'm
glad
loving it in the
that
sense that it's like just got wrecked by just the funniest way. This is like the classic microbyte. Like, what's the HTTP one that they always have? Like the world's fastest HTTP server. And it's like all these languages are always manipulating it to make it like the best possible version.
Yeah.
So it's just like, this is it again. I mean, he's technically right. You don't even need to allocate the whole string because the reality is that the minimum distance is coming from a small string anyways.
Yeah, exactly. Like maybe this was a legitimate benchmark optimization as far as this benchmark is concerned. I have no idea, but holy cow, man, that is sus. So let's take a look now at what actually happens. So let's go get that weird, they've got this really weird, what's the word for it? Hyperfine. They use this syntax for hyperfine, right? So here's that hyperfine syntax that they were using. I'll try and dump that in here and see if we can get it to so just so we can reproduce some results here.
That'd be the ideal format.
So let's dump it in there and see if we can get this to run. And now I'll go ahead and I'll also, while we're at it, I'll remove that. So. Well, I guess they're both printing out the max. This is fine. So we'll just leave it that way. But, see if we can get this to work here. I remember this was a pain last time.
Yeah, wrecked.
Let's see. What did I do wrong? Is that not how it works?
I didn't see the hyperfine command. I think you're close, though. Here, I'm gonna look right now. Hold on.
Okay. Oh, a value is required for warm-up number. What was okay? I just missed the 2. I think that's all it was.
Yeah, warm up 2, and then yeah. You gotta warm it up, baby. Okay, you gotta
all right.
Put your hands to the fire. Woof.
So here we go. Right, we're running it, and we are reproducing, roughly the same thing as they were getting on that benchmark. Right, the C version is slower than the Fortran version. So as we know, this means you should rewrite all of your mission-critical, performance-critical code in Fortran because this benchmark created by experts for experts is telling you that Fortran is 10% faster or whatever it is on this benchmark, right?
Yeah, objectively.
Problem solved. Problem solved. Now, what happens if we actually tell the Fortran version it should use the whole string, right?
My guess is that it's going to be like we're talking like
right.
easily into 28 milliseconds. We're going to be going a lot slower all of a sudden.
So let's try the whole string now and see what happens. Like suddenly we get a different story. Right? Now our C version is faster than our Fortran version. Why is our C version faster than our Fortran version? Probably because the Fortran version now actually has to do the work that is required of the benchmark, which the C one was doing and the Fortran one wasn't doing before, but nobody bothered to check, right?
Cinema. This is pure cinema right here.
So that, right, what happened there is obviously really bad. But again, just to underscore how bad this benchmark is, we really haven't learned all that much. We learned that the benchmark is bad, but we already knew that. But if you go ahead and look at what happens up here, for example, in the Fortran code, there's a lot of stuff like length trim and like these are allocatable, string 1 and string 2. And I don't, and it like this says allocate. So this is doing a dynamic allocation for these two things, for these row buffers here, right? And the C version just uses a stack alloc A, I guess, on here, right?
Yep.
So again, not really comparing apples to oranges. So this is also misleading because you probably could make the Fortran code go roughly the same speed as the C code if you wanted to, if you just rewrote the Fortran benchmark slightly. Because as we saw, the actual inner loop assembly that was generated was the same effectively for both, right? So you know that this is also a lie. Like, this is a lie, this is also a lie, and it just gets back to the same thing I was trying to say before, which is this is a bad idea. This benchmark should not exist. Like, it is not done properly, and this is not telling you important information about this language. And I was a little bit calmer about it last time we talked about this, but now that I'm doing it, having to do it again for the same benchmark, I'm getting like increasingly agitated, right? Like I'm just like, someone needs to stop these people from doing this. It's creating so much misinformation for no reason. Right?
Well, I think the good news is that just talking about it and showing these kind of things just goes to show really a lot of the dangers also of benchmarking. I think a lot of people in amateur ways, including myself, have benchmarked things throughout our career and made things faster only to realize that when you go to production, nothing actually changes. And that's because a lot of times your methodology, your soundness, what are you actually testing for, your controls? Like, do you have one control? Are you having confounding factors? All that stuff all adds in. And if you don't have like a real, at the end of the day, output that you can say, hey, in the actual real thing, we are now officially faster or we are now officially slower, it just goes to show that like this type of practice, even if it's fun to do, you might draw bad conclusions. You might not, or just conclusions that don't even matter, or conclusions that are just like that actually can influence you, in fact, in like negative ways too.
Absolutely. And so I would recommend that, you know, like I don't really know what the appropriate way of actually like clearly articulating to people that they need to ignore, like they need to really just consider this, you know, just bad information. Like don't, like this is just bad and anything that comes out of this GitHub, ignore it, right?
Yeah.
But I would recommend that, yeah, the people who work on these languages to the extent that they can, come out and say how ridiculous this is, right? I mean, I have not looked at the Zig version. I have not looked at the Nim version. I've not looked at the Go version, not looked at the Odin version, et cetera, et cetera. I guarantee you that if we went and looked at them, it is not representative that Fortran is twice as fast. Even after fixing that bug, there's no way that Fortran, or C for that matter, is massively outperforming these other languages legitimately. That is not a very likely outcome. Does maybe Zig have some bug in some code gen thing somewhere that's causing this to happen on just this benchmark? That could be, right?
They could also be just programming it differently too. They could just be programming it incorrect. There could be things about it because
if we open up the benchmark, exactly. If we open up the benchmark, it might just be a garbage implementation in Zig. And that is not representative of what the performance of that language is going to be when you actually use it, which is why this is such a bad thing to be publishing. No validation. Like, you need to validate the benchmarks. You need to validate the quality of the implementations and ensure that they're all roughly the same, right? They have to be good quality ones. And it's not sufficient to just say like, well, it's the responsibility of the Zig community to contribute a well-written, but no, it's not.
because you
if
can't
you're the
create a
one
project,
publishing this
yeah.
benchmark, it's your responsibility to make sure you've got a good Zig one. And if you don't have a good Zig one, don't include it on the list. Right?
Yeah. Or if you don't have the confidence that you even know it's a good one.
Yes. So it's irresponsible. And so I feel like the other language maintainers should come out and say this definitively. People should very clearly state that this is a bad benchmark and people should not be looking at it.
Yeah, I wanted to see. I'm trying to see how to compile Zig in release mode. Because it's not going to use O3. It's O release. There we go.
Yeah, I don't have a lot of experience
I knew it wasn't O3. Let's see if it's O release.
Knowing what the right compiler flags are going to be for, did you make the Go sample correctly? I just don't know. But for the languages I spot verified, I was like, oh, this is a mess.
Yeah, because the only thing that I see about the Zig one that could be potentially causing a little bit of a goof to it is that it's doing, it has a min that's calling another min instead of doing the little min three-way that they had in the C one. Maybe that one's just not getting inlined as well.
Yeah, that stuff like I said, haven't looked into, but it would be shocking to me to find out that on code this straightforward, where basically all the language has to do is hand a trivial block to LLVM for compilation. I just refuse to believe that they've messed up something so badly in, one of these native languages, right? It just doesn't stand to reason. And so I'm just expecting that if I were to go investigate the Zig version, I would find something equally stupid going on to what I just found with Fortran. And that the reason that it's slow is not because inherently you can't write a Levenstein distance loop in Zig and have it compiled to the exact same block of code we just saw C and Fortran both generate.
Yeah. Right? I'd say the very easy layman's one, even beyond any of this, is that you can just look that Go is outperforming Zig. Like Go has to set up a runtime. Go has lots of things that are happening. Yeah. So whatever's going on, whatever's going on, something has obviously gone wrong here.
It just doesn't stand to reason. And that's, again, why I'm so critical of this benchmark. That before pushing send on this chart, anyone who was a responsible benchmarker would have gone, that doesn't look right. Let me at least go validate these results. And they clearly didn't even do the minimum necessary validation because, as you saw, in about 10 seconds, I was able to validate that the Fortran version was completely messed up. And that was probably one of dozens of bugs we would find with the way this benchmark was constructed. I kind of makes me want to go see what's going on with Scala native.
Careful, gotta get that tie-dye shirt out for that one.
Mm-hmm. So anyway, that's my annoyance for the day. I apologize for being so annoyed at it, but like I said, the first time I try to maintain my composure, second time I have to do this, now I'm starting to get grumpy. And so it's like, I don't know. And gosh, I hope they don't introduce yet another fourth benchmark, because then I'm going to be back here. I'm going to be screaming, Prime, I'll be clipping the microphone the entire time.
It's okay. Actually, I'm actually very happy all this stuff happened. I know you're very upset because this is an opportunity in which, right. Remember, the last video we did together here, not to, toot my own horn here. Hold on one second. Let me just pull this up really quickly. I know it was not very long ago. Let's see if I can see this. Let me see if I can see this. The ball diagram one. Yeah, that one. It has 200,000 views on it. So 200,000 people ended up watching it for some amount of time, and so 200,000 people are going to go, oh, huh. Or I don't know if 200,000 is like I can't say there were actual people.
Who knows?
Yeah, right. All that stuff, but nonetheless, people watched it. They learned, and then there was a lot of people that learned from this opportunity, including myself. I learned some things from all this as well, which is just like I like to take these and look at it in the more positive light, which is by someone screwing up in a very, or not intentionally, it's hard to call it a screw up, by someone doing something naively in a very public environment. It allows somebody with more expertise or more experience to be able to come in and say, hey, here's why these things are wrong. And now everybody is just +1. And so when this video comes out, hopefully, again, the +1 is just this is how important correctness is, especially when it comes to a comparison.
Yeah, except, I guess the only thing I'd say there, I like the positive spin.
Thanks.
And I do think, hey, it gives us an opportunity to talk about this stuff, which is good. But I think the problem is all the negative information still got out, and I don't know how effectively it's been corrected. And as much as I mean, we just talked about languages. As much as I kind of don't care that much about languages these days, like we sort of said, I'm still just programming in C and whatever. I do feel for, like, I don't want to be the people who are responsible for Zig, and this benchmark comes out.
Yeah, because
Right?
now you have obligations to something. You're just like, I don't even want those obligations. I never even asked for them.
This benchmark author, by being irresponsible in this way, and they've been warned many times, right? They were warned on the previous ones that they were doing this incorrectly. There are many issues raised on their GitHub itself, people telling them that this is not a good methodology, that there are problems with it, and they're persisting. So at some level, it's like, it wasn't just a naive, like, oh, that, you know, because I would have a lot more patience with somebody who was just trying their best. This was not, this was like, it's ignoring people trying to tell them that this was creating problems for people. And again, I feel bad for these language maintainers now, because they're put in this position where their language is made to look bad on a massive scale. Like, that tweet was spread all over the place. It's making their language look bad, and it probably has nothing to do with their language, right? It probably is completely unrepresentative of anything about their language, and it puts them on this unnecessary defensive footing or makes them feel bad about it for no reason, right? For no real reason, and it focuses their attention that would have been better spent doing whatever the latest thing they were going to do on their language, doing that. Instead, now they've got to respond to this like, oh, your language is way slower than Rust, right? Or whatever. Fortran, you know, it's like, it's not. This is probably a lie, right? And so what can you do?
Yeah.
So there you go. That's why I'm so annoyed at it, is because of that part of it. And yes, the people who we're able to reach, maybe that, like, that's been corrected, but that's probably a subset of all of what went on with the, you know, with this benchmark, unfortunately, because it's got so much traction.
Yeah. The good news is it got a lot of attraction on Twitter and attraction. And so at the end of the day, everyone looked at all these and was like, wow, look at that. Look how fast these are. I'm going to go back to writing this React component. And then that was like, you know, that's like the end, you know, so it's probably okay. We're probably
Good point.
okay.
Good point. Maybe I'm overstating, because everyone's like, wow, Fortran is faster than Rust. And then I went right back to programming Rust, right? So that, you know, it doesn't matter, right? Yeah.
It's fun, though.
Possibly.
This was awesome. This was really, really good. I can't believe you caught a bug and all that. I mean, to me, I'm surprised about it. So amazing work, though, especially since it was just like so straightforward.
Yeah, I mean, and who knows how many more there are, like you said. Like, that was, I literally looked at just the top one of the list, and I found a bug right away, right? Like, it wasn't like I spent 40 hours digging through all the code and found this. Was like, nope, first time out of the gate, and it's broken. So
yeah, one could imagine that the Rust one probably has it.
I
Odin,
have no idea.
Zig.
Yeah.
You could probably
once
just
again,
go down.
One of the problems, again, with testing like this is those millisecond times are really way too low if you're looking at command line startup times, because all languages have to make trade-offs in that regard about how they're going to do, what kind of memory provisioning they're going to do, what kind of thread stuff they're going to start up at runtime, and all this other sort of stuff. And when you're talking about low millisecond times like that, a lot of times the startup hasn't been optimized to try and get that down for situations where you want extremely fast command line turnaround. Now, that's not to say that I don't think a very mature language should probably have ways of adding some directives to make sure that your startup time is as fast as possible. Absolutely, that's a good thing to have. Do I think that's an important thing for Ginger Bill to be worrying about on Odin right now? No. It is the least important thing for him to be worrying about, because 99.999% of programs don't care if their startup has an additional 10 milliseconds in it, because most of them are load and long run, right?
Yeah.
Most of them aren't like a compiler where like the turnaround time on the command line is something we're actually measuring. Most of them are like this application. You're running Embergen. If you can spend an extra 10 milliseconds at startup to get you a bunch of performance or to get you a smoother thing happening later on, that's a good trade-off. And you don't want to bias against that because most programs would rather have the latter. And so again, even if we assumed there were no bugs, one of the problems is this is not enough work to be timing on a startup, run, and exit benchmark, because you're starting to get into a lot of OS things, page fault things. There's all these other sorts of things that you might be looking at there, depending on what the language has to do when it starts up. And so, as people have said over and over and over again to the person who made this benchmark, you really should just be timing things inside what the languages are doing, because startup time is a really bad, because there's different trade-offs you might make there. But if you are going to include startup time, you need to at least have enough work that the startup time itself isn't like in that same range as the work amount, right? Or you're in trouble.
Yeah.
So.
Well, awesome. Thanks for being on here again. This was great.
Thanks for having me. Thanks, everyone, for listening to another benchmark rant. And when they invariably ship another one of these, I'll be back here.
Let's go.
And I'll try to remain calmer than this time. Thanks, everyone.
Well, this is very exciting. I feel like there's, I don't know if I could give my hand at making these any faster, but it kind of feels like there's a lot of just a funness in there just to go look at, because I just don't even understand why they're different. And so it just seems exciting.
Yeah, and ideally that's what a benchmark maintainer should be doing. That's their job. They should be looking, and this is why when I tweeted at this and when I first complained about it, I said, please stop pushing benchmarks without the analysis. You got to have the analysis, right?
Yeah.
If you do this benchmark and then you go find out why each one is the speed it is, that's so valuable, right? If you just post this and go like, YOLO swag, that's completely useless, because, maybe you're just mostly benchmarking bugs, and it turns out that's exactly what's going on here.
It is. All right, awesome. Well, thanks, Casey.
Thank you. Pleasure being on the show as always. Thanks everyone for tuning in.
I forgot the most important part. What computer enhance? Computer enhance? Because how did you get all of this valuable and amazing knowledge? There must be a place in which I can go to get this.
If you want to sign up for Computer Enhanced, this is what we do there. If you want to learn to read that assembly language and know why I looked at it and said it looks pretty good, well, this is where you go. This is where you go to find me. This is what we do all day over at Computer Enhanced. So yeah, check it out if you want to learn that stuff. I imagine most of your viewers know that by now, but thank you for the plug, Prime. I do appreciate it.
No problem. It's awesome stuff in there. I still get the emails, and I look at them. I'm like, ooh, I want to look at that one. I want to look at that. I just find I don't even have enough time to look at all of them. They're so good.
It's a embarrassment of riches. An embarrassment of riches.
It is. It really is.